Okay, so hi everyone. I think I'm audible and visible to all of you. So shall we start with the class, guys? We'll wait for some time so that all of us can join and then we can start with the class. Yeah. So good afternoon, everyone. So Antonio, Sachin, Mayam, Doctor, everyone. So good afternoon, Ravi. Good afternoon. Yeah. So we'll wait for a couple of minutes, guys, so that all of us can join and then we are going to start. So today class is going to be very amazing, I would say, because we are going to build something which is very real, but don't expect that code is going to be easy. And so I don't think that it's even going to matter. Code is going to be easy or hard because either me or you, none of us are going to remember the code. We understand the concept, we understand the layers, we understand what we are trying to build. So anyhow, you will be able to build it. Yeah. But for sure, we whatever we are going to build today, I think with the help of this, if you have a huge amount of computation, if you have a like a just a computation power, compute power, if you have, you will be and the data obviously. So if you have like a data of the entire world, you will be able to build something beautiful by yourself. Excited for today's class? Yes, but don't feel frustrated in between the class because code is not going to be simple as we are going to build something real. I'll try to explain each and every line of the code, so don't worry about it. But again, coding is like a secondary thing. Concept is a primary thing. Fine, guys. So we are going to build basically GPT 3.5 kind of a system, a complete GPT-3 kind of a system. We are going to even visualize the model. We are even going to check what is the number of parameters that we are trying to train. Everything means everything end to end. We are going to do it from a scratch without like using any pre-trained model or anything. Make us feel easy, sir. I will try to, but again, so it's a two-way journey, right? When these kind of a things comes into a picture, obviously it's a two-way journey. I'm expecting that we understand a Python code, at least like I'm not going to talk about a basic of the Python fundamentals. I understand. I think we all have that much of understanding. So if that is fine, then I don't think that you will feel overwhelmed by a code. Okay, so 2 more minutes, guys. We are going to wait, and then we are going to kick off the class. Okay, so I'm going to share my screen and I'm going to open up a VS Code. So just open up a VS Code, guys, or maybe you can try to open up a Google Colab. That's completely fine. I just need a Jupyter notebook, kind of a setup. That's it. So whatever like make you feel good, it's completely fine. Go ahead with the Colab. Go ahead with the Jupyter, any online version of it, or maybe go ahead with the VS Code. I believe we have been using or we have been coding inside a VS Code. So I'll try to follow the same, the system that we have been using since the beginning of this class. Are we going to train the model for some of the data? Exactly, Pratyush. So we are going to create our own data. We are going to train our model. We are going to create our own model, our own tokenizer. We are going to train it. We are going to save the model. We are going to test the model, that whether my model is able to generate something or not, just like exactly like a chat GPT. So for example, you are going to ask something to a GPT, right? And chat GPT is going to give you an answer. So exact same thing we are going to do, and we are going to follow the exact same ChatGPT 3.5 kind of architecture, the architecture that I have already discussed in my theoretical section. Fine, Pratyush? And I'll keep on giving you a code. Don't worry. So even you can do coding in parallel to me, and you can, if you're getting stuck somewhere, so maybe just copy and paste the code. So I will copy and paste a code inside your chat box in a real time so that you will be able to even code it along with me. Okay, let's get start. So first of all, guys, open up VS Code, and then we are good to start, I believe. So all of us is having a VS Code open and ready. So I'm going to create a folder, by the way. So open folder, and then maybe in a directory. So I'm going to create a folder called as GPT. So this is the folder I'm going to create. And inside this folder, I'll try to keep all the files. So simple, open up a VS Code, create a folder inside a VS Code, and then I'm going to create a Jupyter notebook file, IPython notebook file, IPYNB. So gpt.ipynb. So this is a file I'm able to create. And yeah, so here I will start coding each and everything. Now, along with that, so try to create another file, basically data.txt. So here we are going to keep our data, a data which we are going to pass to train my own model at the end of the day. Yeah. So yesterday class was missed by me. So yesterday I was talking about a comparison between the architecture, and before like yesterday's class, which was like a last Saturday class. Sunday I have not taken, I believe, a class. It was a holiday for me because of Ram Navami. Basically like if you have attended that class, that Saturday class, last Saturday class, so I think then it's fine. But yeah, all these classes are linked, obviously. Okay. Can I use a UV environment here? Yeah, you can use it. I don't have any kind of a issue, Sachin. So sorry, Sachin, I think I'm not able to pronounce your name correctly. Okay. So data. Now here I'm going to create a data. So I'm going to create a like a very own kind of a data. My name is Sudhanshu Kumar. I work with Euron. Okay, so instead of creating this data, what I can do is, so anyhow, I'm going to fill a data about me, right? So I already have a founder story page. So I'll go and I'll copy my own story from here. So yeah, you can just go over there and then copy my story if you want. So I'm just going to take this data. So this is about me, guys. This is my story, which is you will be able to find out on a founder's page. So let me copy the story. Control C. Okay, let me copy other part of the story. The entrepreneur and teachers Dhanshu's dual legacy. So copy this data. Okay, let me check early life. So yeah, this is my early life, by the way. You all can go and read out. Rising through the ranks of tech world. Let's copy that data. The birth of Neuron. And then the foundation of Euron. So this is the data, guys, I'm able to create. So basically I have copied this data from my own founders page. You all will be able to find out a founders story page on Euron itself. So even if you want, you can go and you can try to copy, or else I'm just giving you this entire data set inside your chat box. So this is the entire data set, guys, that I have copied. So this is the data set I will be using. So where things are mentioned about me and my early days, my career, how I have found my previous company, how I have raised the capital in my previous company, and then I sold my previous company, then why I have started the new company. Everything you will be able to find out. Teacher plus entrepreneur journey, plus a techie, obviously. A teacher, entrepreneur, and techie journey, you all will be able to find out in this one. And I have just copied the data. So this is the data, guys. Please copy it, keep it with you so that we can try to use it. Yes, everyone? Done with data? Yep, I believe you all are able to copy the data from your chat. So just confirm, ping me yes or no, guys, inside your chat box. We'll go in a step-by-step manner. So the very first step is prepare your data, because obviously we are trying to build a conversational system, right? So basically we need a data so that I will be able to train my model, so that my model will be able to generate something out of it. Yeah. And this is the data I'm going to use, my own data, my own story. I'm going to use it to train my model. And then while generating or while asking some of the questions, so maybe I'll try to ask something out of this data. We'll see whether my model is able to respond or not. And if my model is not able to respond, then what I can do to make it more powerful, to make it more like robust, so that it will be able to give me an answer in a correct way. Yeah. Uh, Rathlavat is asking, hi sir, I'm currently working as an AI engineer where I fine tune LLMs and VLMs. Fine. I have already covered a basic like pre-processing and tokenization in a previous courses. Since this is my first class with you, just wanted to check, will I be able to follow along with the content? Yeah. So if you if you are claiming that you are already working, so I think you will be able to follow along easily. I don't think that you will face any kind of a problem. Yeah. Okay. So data set is ready, guys. Now we'll come to a Python file, and let's write 1+1 just to import the environment. So import the environment. So I'm just going to use my own base environment. Going forward, I'm going to teach you that how to create basically an environment, virtual environment basically. But yeah, I'm not going to create a virtual environment over here. I'm going to use my base environment. So fine. Now my data is ready and my Jupyter notebook is ready. Now what is the procedure we are going to follow, guys? So what I will do is, so we'll try to open up a research paper, the research paper that we have already discussed. So attention is all you need. So this is the research paper that we have discussed, right? And this is the base. So we'll try to follow along with this research paper. So obviously I'm going to basically create a GPT kind of a model, and we all know. Okay, one question for all of you. So guys, GPT is a decoder only model, encoder only model, or encoded decoder model? Yes. Okay, Ramesh. Yeah. So guys, question for you. So GPT is a encoder model, decoder only model, or encoder decoder model? Okay, I believe we all know the answer, right? Everyone is saying decoder. No one has given me a wrong answer. Okay, now Ratlavat is saying encoder and decoder. No, it's a decoder only model, by the way. So the initial version of GPT, by the way, the initial version 3.5, if I'm going to talk about. In a later stage, so obviously there is a modification. So 4.4.0 mini and all those models. But yeah, so if I'll talk about the initial version, 3.5 practically, which was like one of the early version of a GPT. It's a decoder only. And then in a later stage, when they have started improvising, so they have attached encoder, decoder, both the segment for a different task. And then even they have introduced a mixture of the experts where there are multiple models. So this is something that we are going to follow, this architecture we are going to follow. And the very first part that we have to do is, so we have to read the data, and then we have to convert those data into yeah, Ratlavat is saying, yeah, initially, so that is something that I have discussed in my class, and we are going to build that particular part, basically. Yeah. So not a latest one, because latest one architecture is not exactly available to all of us. So here, the very first part that we have to do is, so we have to take a data, the data that I have taken over here, and I have to encode this data. I have to convert this data into its numerical representation. That is a part number one that we have to do. Part number two is that we have to attach a positional encoding. So I believe we talked about a positional encoding, a rotatory positional encoding. This is something which has been used by GPT models. If I'll talk about just this particular research paper, then it was a simple odd even number positional encoding. We have already talked about the mathematics behind it yesterday itself, right? But yeah, so if I'll talk about a GPT, so GPT 3.5 or early version of GPT, it was using a rotatory encoder model. So we are supposed to prepare the data in a very first place. Once my data will be ready, then what I will do, I'll try to create a layer one by one, bottom till top. I will try to create a layer. I will try to send a data layer, means I will try to create an entire model. And then eventually we are going to visualize that particular model as well. So we are not just going to create a model, as you can see in my screen, right? I believe my screen is visible to all of you. So this is the visualization of the model that we all will be able to get with the help of Neutron. We are going to save the model, and then one by one, layer by layer, we can even try to visualize the model inside a Neutron, or even inside our code. So we can try to call model.summary. That is going to give me the complete layer by layer, that what model is trying to do and what is the structure of the entire model, one by one. So that's a whole idea, guys. So we are going to follow the, like I said, same research paper, and one by one we will start building, or we will start writing the code. Okay, so let's get started now. So here data is ready. Now code wise, before I started writing a code, so I have to do some sort of a import over here, right? Some of the libraries which I am going to use, I have to create couple of variable which I will be using eventually for this one. So the very first library, or the only important library that we are going to use over here, is basically TensorFlow. So I'm going to use a TensorFlow TensorFlow as TF is an alias. Then from TensorFlow dot keras, I'm going to use a high level API from keras import layers basically, and then try to import numpy as np, then try to import OS model so that I can read out the files, and then try to import a pickle so that I will be able to save some of the models. The tokenizer model that I'm going to create, or any other model that I'm going to create, I will be able to save it. So I have already pinged you a code inside your chat box, guys. So these are the import that you have to do. If you are getting some sort of an import error, just do pip install and that particular model name. That's it. So here, import is done. Now, once import is done, let's try to read our data in a very first place, right? So our data is available in the same directory, right? Data.txt. So I'll try to read out the data. So simple Python code with open and open what? So open my file data.txt, simple, and try to open it up into a read mode basically. And encoding wise, while trying to read out, so just try to use a UTF-8, which is equivalent to a English. So UTF-8 encoding technique, use it and read it. So as F, and then I can try to write F dot read the file, and I'm going to save it inside a variable called as text underscore data. Fine. So just try to read a file over here, execute, and now if I'm going to show you a text data, I have the entire data set. So whatever data which was available inside my data.txt, now with the help of my Python code, I'm able to read it out. So here is a code I have pinged you to read a data. So fine, library import is done. Now this data read is done. So I'm able to read a data. Now once I'm able to read a data, right? Now what I'm supposed to do? So if I'm going to follow this research paper, right? This research paper. So once I will be having a data, so I have to convert those data into a embeddings, right? I have to convert this data into a embeddings. Embedding simply means that I have to convert those data into some of the numerical representation. We have to tokenize the data. We have to convert those data into some of the numerical representation. So fine, let's do it then one by one. So I will be using a library over here. So instead of going ahead with the manual approach, I think we have seen the embeddings, different kind of embeddings, but here simple library I'm going to use. So here what I will do is, so I'll be using a TensorFlow library. So TensorFlow.keras. So keras is a high level API, preprocessing, and then preprocessing text, and then do what? So tokenize. There is a library called as tokenize. Now this is going to help me out in terms of tokenizing my entire data set. As simple as that. So are we able to follow along, guys? Yes, everyone? Yeah. Can you please share the data.txt again? You please look into the chat. I think you will be able to find out. Or just take any data, any random data, that's completely fine. Take your own set of the data, that's completely fine. Yeah. I have taken my own data, my founder story page. That's it. If my data is a multiple PDF Word file, then then write a Python code, read all the files one by one, and then create one final data set. Simple. I think with the help of Python, I can read not just one, I can read a millions of files separately. Even if my files, some of the files are available in a Word format, some in a PDF format, some is available into a markup format, some is available over a HTTP. So I believe we know the library called as Pandas. Now Pandas is going to help me out. Or even if I don't know about the Pandas, that's completely fine. Just by using this one, I'll loop it through and I will be able to read the data. I mean, like, it's just a Python problem, right? It's not a AI problem, by the way. Okay. So once I'm able to read out this entire data set, now what I will do is, so I will try to, like, I have to tokenize this data. Now, if you look into this tokenize method, so it always try to talk about a number of words, right? A number of words that you would like to tokenize, means a number of unique words that you would like to tokenize at the end of the day. Now, if you will come over here, you will be able to find out like its meaning as well. So number of words means the maximum number of the word to keep based on the word frequency. So only the most common number of word minus one will be kept. So the unique number of word that you would like to send to your model to understand something, right? Now there is something called as OOV token. So if given, it will add the word index and use to replace the out of vocabulary word. Simple. So it will try to replace all the out of vocabulary word. And that is something that we have already discussed while talking about the embeddings. So here I will try to set a parameter. So number of word. Let's suppose I want my model to learn 5,000 unique word, and then out of vocabulary token is going to be, so out of vocabulary token is going to be OOV. So OOV. Okay. So here inside a string, you have to keep it. So number of tokens and words. Now here I can try to save it inside a variable called as tokenizer. So this is a like an object which I have created, a tokenizer object. Now once I'm able to create a tokenizer object, I can try to call tokenizer dot fit or dot fit on text. So on text, I will try to fit on what text I would like to fit. So I would like to fit this on this text data, the data which I am able to read, my own data, right? My own data that I'm able to read. So I'll try to fit it over there. So I'll try to pass that data as a list in this particular place and then execute. So once executed, it is going to create a tokenization of the entire data. As you can see, it has created a tokenizer, right? Tokenizer means now it will be able to convert my entire document or the data that I am trying to read into a small token. Now here, so if I have to see the outcome, so maybe I can try to call tokenizer dot text to sequence, text to sequence I can try to call, and then text data I can try to pass. So this is the sequence it has created, guys, and one by one, as you can see. So basically there is a array inside a array. So this is technically a sequence which it has created out of my entire data set, right? Out of this entire data set. So I can try to store this entire data set into sequence, this variable sequence. Okay. So inside a sequence, just try to store all this text data. Now let me ping you this piece of the code. So tokenize, convert it into a sequence, and then store it. So this is a sequence. So now we are able to convert our data into a numerical representation. Just call the sequence and you will be able to see that yes, we are able to convert the entire data set into a sequence. Now, so here we have array inside a array, or you can say list inside a list. And then maybe we can try to even check that what is a length of the sequence. So sequence of 0, obviously, sequence of 0. What is the length of it? So in total, we have 860 unique word that system is able to find out inside my data set. Okay, fine. So this is the total number of the sequences that we have inside my data set, in like a unique one. Fine. So here I have to keep a 0 from the 0th indexes. I'm just trying to fetch the data. Yeah, fetch the data. So sequence I am able to create. So just a small correction. Take a data from 0th index because there is a array inside a array that you have. Now, once this is done, once I'm able to create a sequence of my data, now what I will do is that I will try to save this tokenizer as of now. And again, so I have not created an input and output sequence as of now. I have just like converted all the data into its tentative, like a numerical representation. That's it. Nothing more than that, which I am trying to do. So here, what we can do is, so once we are able to create a tokenizer, right, we are able to convert it into a numerical representation. So we can try to store this model. We can try to save this model so that whenever I will try to test, right, even at that point of a time, I'll try to pass my data. So let's suppose if I'm going to ask, who is Ranshu Kumar? So obviously system has to convert that data into a numerical representation, and that should go inside a model that we are going to train. So even at that point of a time, we need a same tokenizer which understands my actual data. So what I can do is, for example, if you are going to ask some question to a ChatGPT, what ChatGPT does, so it is going to convert your entire line or entire tokens into a numerical representation, and that goes inside a ChatGPT as an input. Now, so I need to save this tokenizer as a physical file so that I will be able to use it in a later stage, even at the time of testing or even at the time of generating my content. So here I can try to give my model name to use KENIJDR tokenizer.pkl pickle file. Pickle file I'm going to create, which is nothing but a model file. Write binary is the mode. It's a binary file as f, and then pickle.dump dump, and here, so we are going to dump what? So we are going to dump this object, tokenizer object basically. So this I would like to store it as a inside a file. So as simple as that. Now once I'm going to execute it, you will be able to see that it has created a tokenizer.pickle file, a physical file I'm able to create. Why? Because I'm going to use it. I'm going to use it when I will try to test my model, when I will try to pass a question or any kind of a data, and I will be expecting from the model to give me some sort of an answer. So at that point of a time, I need it. Okay, fine. So just take this code, store it. Yeah. So are we able to follow along, guys, till this point? So we have done nothing much, by the way. So we have a data, we are trying to read the data. We have called a tokenizer. Now tokenizer is able to convert my data into its numerical representation. And then eventually we have saved those model. Yes. Yeah. Okay. So Durga is saying yes. Deepak is saying yes. What about others? There are so many people inside this class. Doctor is saying yes. Ashish is saying yes. Please repeat a pickle. Pickle is nothing but it's a model physical file format. So there could be a pickle, there could be a H5 file format. So there are different kind of a file format in which we try to save the model. So pickle is one of the format in which we are trying to save the model. Just like a .txt, right? .txt, .excel, .docs, .pdf. So we generally, even in a day-to-day life, we are using a different kind of a file system, right? For PDF, it's a .pdf. For example, for IPYNB, so it's a like Jupyter Notebook, it's a .IPYNB, .txt. So in the similar way, for model, it's a .pickle or .h5. In any format, you can try to save it. It's a binary file format. So tried import tokenizer is showing no module name TensorFlow. So obviously, if you are able to get no module name TensorFlow, I think we all know the answer. Simple, pip install TensorFlow, and it will solve the like a issue, Devanjan. Pip install, pip. Plus guys, the best part is you can even try to take a help of Euron. So for example, try to import tokenizer, and that's the reason. So we have given you Euron, right? So try to use all the system. Sorry, I am searching Euron. Basically inside Euron, we have Euron, right? We have given you a beautiful system, guys. Just like use it. See how fast it is. It is giving you pip install TensorFlow, right? Use it. Yeah. You can like you have some of the beautiful model, some of the real-time search which is given to you. So what is stopping you to use it? Some people use job leave as well. You can store it in any binary format. That's completely fine. So it's just at the end of the day like files, right? So file format could be anything, and it is not going to create any kind of a bottleneck for you, for any one of us. Okay, fine. Now, so now what we can do is, so we have like a tokenize, means we are able to create a data into a sequences. Now what I will do is, so we have to create a input data and we have to create basically a output data. Meaning is that if we are trying to train this model, right? If we are trying to train this model, and I'm trying to train this model for what? I'm trying to train this model for a very, very simple purpose, that I will ask question. You should give me answer, right? And if you remember, in your previous class, practical class, so I talked about one of the example of RNN LSTM. So where HEL we were trying to give and ELP we were expecting. Guys, remember that example? I think we have written a lot of code for that. When I print a sequence, it's showing me none, sir. Okay, Deepak. So just try to check your code. Maybe you can check with Yuri as well. Just send all the code to Yuri and it will try to fix it. Fine. Okay. So basically we talked about that help, right? So where we were trying to like pass some sequence and then we were able to generate some sequence. So when I was trying to pass HEL, it was able to generate a next sequence called as ELP. Now we are trying to train our model on this data for the exact same purpose, so that my system should, my GPT should understand this entire data set. And if I'm going to ask some question, it is supposed to generate something next, right? It is supposed to generate something next. Now to generate something, that's a testing phase basically, right? But at the time of training, when I'm trying to train my entire model, so in that case, I have to create my X and I have to create my Y, right guys, everyone? Making sense? So I should create X and Y both for me. How many of you disagree with it? So if we are trying to train, even if you remember the example help that I have given, right? So even at that point of a time, we have trained our RNN LSTM model. We have given our input and we have given our output. So we have given our X, we have given our Y. Now, even over here, so we need our X, we need our Y. So guys, what is going to be my X and what is going to be my Y? Logically, what it is going to be as per your understanding, if you can help me out with that. See, I just have this data, right? I just have this data. I don't have any other labeling with respect to this data. So what is going to be my X? What is going to be my Y? Devans, you can follow along with the chat. Okay, chat is like a too long, so I think it will be a bit tedious for you to like copy and paste. Don't worry, Devans. Like wait for some time. I'll copy and paste once again all the code. Yeah. So Satish is saying X and Y are same. Okay. Anyone else? So guys, the question is very simple. I have to train the model, right? And obviously I'm trying to train for a conversational purpose. I'll try to like say something and model is supposed to reply back with something, right? That is basically a testing phase. But at the time of training, how I'm supposed to train? I need my X data. I need my Y data so that my model will be able to minimize a loss between my X and Y. This is how training will happen, right? My model will be able to minimize the loss between my X and Y. Now, so what is going to be my X? What is going to be my Y? That's a question for all of you. Sadiq is saying X and Y are same. Santosh is saying X is equal to text, Y is equal to encoding. Santosh, I mean like how system can understand a text. Anything that we are going to pass, it will be available into a encoding, means a numerical format, right? In some sequence. Rajat is saying X is equal to current word, Y is equal to next word. Yeah, you are close actually. Doctor is saying 30-70%. No. I think you are not able to like understand the question. No. I'm not talking about that part. That is a different context. Not that. Maybe you are coming from a machine learning background where we do like this straight up things. But no, it's not like that. Input will be before word and output will be next word. Yes, Sachin. Yes. So I think we have a couple of right answers. Sachin and Rajat, like they have given the right answer. We mask our data. That is the approach, Sandeep. I'm talking about just an input and output. The masking is one of the approach that we try to integrate in between. Okay. So we have to create input and output. Let's do it. I'll try to write a function over here so that this function will take the input. Obviously, like a sequence input, it is going to take, right, the sequence that we are able to create, because this is our data, right? The sequence is representing our data. So this is going to take the sequence input, and then eventually it is going to create my X data and Y data, because I just have only this data. I just have sequence data. Apart from this sequence data, I don't have any other data set. So here I'll write a function. So write a function to create a data set, create underscore data set. So out of the sequence, hope you are able to get a sense that why I'm writing this function. So I'll try to pass a sequence over here. I'll try to pass the sequence over here. And then there is a parameter I'm going to create, a WINDOW window size. Window WINDOW underscore SIZE window size. Window size is equals to maximum sequence length. So we can try to give maybe something like a maximum sequence length over here. So maximum sequence length, let's suppose I'm going to give 32. So max to max, this is the sequence it will be able to understand. I'm just giving, you can change the sequence to any number that you want. Then input is one of the variable, label is another variable. Label is another variable. So I'm going to create and keep it empty. So two empty lists I have created. One is a input empty list and one is a label input list I have created. Now what I will do is I will try to go through the entire sequence. Let's suppose as a sequence, I'm going to provide this data. Now we know that this data is available in what? This data is available in a list format, right? We all know, even you can go and check. So how this sequence data looks like. So basically it's available in a list format, right? 860 data or 860 values that we have. It's available into a list format. What I will do is I'll try to iterate through it, right? So for I in a range of length of basically a sequence that we are going to provide, simple, I'm trying to do a iteration minus window size, right? Minus window size. And then what I can do is I can try to write input, the input variable that I have created, the empty list dot append. Now append what? So we are going to append over here a sequence starting from ith value to I plus window size. So this is one of the data, and then labels is going to be what? So labels dot append, and this is going to be what? So sequence of basically I plus 1 I plus window size plus 1. As simple as that. Now, how many of you are not able to understand these two lines of a code? I think someone has told me already. Some of you have already, Sachin or Rajat has already given me an answer saying that your X data is going to be a data, current data, and then Y is going to be starting from a next data. For example, so a simple analogy, if I have to build over here. So let's suppose I have a word Sudhanshu. So what is my X, let's suppose? Just imagine, right? So my X is going to be, let's suppose SUDH, right? Let's suppose my sequence length is equal to 4. Here I am taking 32, window size equal to 32. So here X is equal to SUDH, then Y is equals to what? UDHA. Fine? Yeah, UDHA. So it's a very simple Python code. That's the reason, guys, I told you in the beginning itself. So I'm not expecting that I will explain you a simple Python code. I'm assuming that we all understand the Python code. We'll try to focus on the core part of it, right? Okay. So this is something that we are trying to do. So sequence, start from I. So I till a window size that I have given, right? I plus window size that I have given, and then window size nothing but one simple number I have taken. So starting from one point and then going till one point, that I'm going to treat it as an input, and then from that point plus 1, right, I'm going to treat it as a output, Y. As simple as that. I have given you example of SUDH, right? Sudhanshu. So it's the same thing that we are trying to perform over here to create my X and to create my Y. Let me explain you once again. So let's suppose I have a word called as SUDH, ANSHU. So my first X is going to be, let's suppose, SUDH. My window size is going to be, let's suppose, 4. This I'm considering as a 4. Here I am considering 32 long sequence, but yeah, let's suppose I'm considering 4. So SUDH. What is my Y? Right? My Y is going to be UDHA. Right? So this is my one of the X. Then this is my one of the Y. Then what is my next X? So my next X is going to be UDHA. What is my next Y? So DHAN. What is my next X? My next X is going to be DHAN. What is my next Y? So HANS. What is my next X? Next S. So it's HANS. Then what is my next Y? ANSH. Making sense, guys? My X, my Y, my X, my Y, my X, my Y. I'm able to create this pair. Any reason for choosing a window size equal to 32? No reason at all. It's just a hyperparameter. You can choose maybe 100 you can take. That's fine. Yeah. So it's a hyperparameter. I will try to test it and I'll try to fix it. Making sense, guys, how I'm creating X and Y? I think now it's clear. Yeah. Same thing I have written inside the code. See, start from I, go till I plus window size, start from I plus 1, go till I plus window size plus 1. Yes. Yeah. Okay. So this is something that we are able to create. So this is my X, this is my Y, X, Y, X, Y, X, Y, X, Y, X, Y kind of a pair I am able to create. So that model will try to understand this and it will try to minimize a loss for this. Understand this, minimize a loss for this, and so on. Model will keep on doing it. This is how we are preparing the data. Okay. So once this is done, then what I will do is return, basically. Return, RETURN, return. Now return what? So NumPy array. So NumPy array and of input. Convert this list into the NumPy array. NumPy dot array and basically LA labels, right? So I'm just returning these two things. So list. So I'm returning as a array over here. So this is what this function is going to perform. Execute. Now call this function, pass the data, get the value. So I'm calling this function basically. I'm going to pass my sequence. What is my sequence? This is my sequence. I'm going to pass it. So take this value data, the data which I have converted into a numeric format, right? So pass this data and then window size is equal to 32. I have already given. So fine. Now create it. Now can I say that I'm able to create my X and I'm able to create my Y? This is my X data, by the way, and this is my Y data, by the way. Is it making sense? And are you able to resemble it with the analogy that I have given to you, Sudhanshu wala analogy, right? 158, 159, 16. See, next one is starting from 159, 16, and so on, right? Everyone? Got it? Yes? Yeah? So we are able to create our X data and we are able to create our Y data. If you would like to dig deeper into it, you can go ahead and obviously you can try to dig bit deeper into it. So maybe I can try to hold this data into X data. So X underscore data, I'm getting two output, right? So Y underscore data in which I can try to hold it. Now X data. So here, maybe I can try to check the length. So there are 828. Now X data of basically 0. Can I say this is one of the sequence? Total 828 such X it has created. 828 such record it has created. Now X data, this is the first sequence. You can even validate it like logical validation. So Y underscore data and then what is the 0th Y. So for this X, it will try to learn with this Y. If this is the input, this should be the output it will be expecting. This is X of 0, this is Y of 0, then X of 1, Y of 1. I think this is what I was talking about, right? By giving you an example of Sudhanshu. And window size I have given 32. Can I say that 32? This is 32. One of the sequence is 32, by the way. Yes, one of the sequence is 32, by the way. Can I say that? So like number of basically when you do a machine learning, right? So you write x1, then x2, then x3, then x4, then x4, x5. So this is the number of columns, right? So what is the dimension? 1, 2, 3, 4, 5. 5 dimension. So what is the dimension of this? 32 in a vector space. Yeah, completely understood, sir. Someone is saying like they imagine confused what to do. Nothing, follow along. I don't think that it's that confusing. Yeah, if you have not joined a previous class, if you are like coming out of like a without joining the previous classes, then obviously you will feel difficulty. And if you don't know Python, then obviously you are going to feel like a difficulty. So array dimension 32 because of window size. Obviously, this is what it means, right? So just try to do a windowing. For example, if I'm going to like keep it as a not 32, I'm giving 100. Let's suppose. Okay, fine. Now see, changed, right? 100, 100. So one x is 100, then another x is like x 100, y 100, right? And now if you are going to check, so 760 such data it has created for me, right? So input sequence, I can just try to play along with it. That's it. The way I want. Okay, making sense. Now, moving ahead, right? Now, once we are able to build this data, now follow the architecture. So we are able to basically build the input data embeddings. Input data, we are able to build it. And basically we are able to convert our input data, X data and Y data into a numerical array representation. It's done, right? 100 vector. So 100 vector is like helping me out to represent that. Now, what is the next step that we have to do, guys? So what is the next step? Yep. What is our next step that we have to do? So can I say that I have to include a positional encoding now with our data? And why do we include a positional encoding? I think we know the answer, right? So what is the advantage of taking a positional encoding? I think we know the answer. Now, so what kind of input embedding we have already done, right? Input embedding is done. This is what an input embedding is, right? This is the input embedding and output embedding. So input embedding we are anyhow we are able to generate with our own dimension. Now we have to do a positional encoding. Yeah, positional encoding. So Papa is saying positional encoding. Okay, that's amazing name, by the way. So positional encoding we are able to do. Now the next part is what kind of a positional encoding GPT 3.5 is using. What kind of a positional encoding GPT 3.5 is using? Is it going to use the same formula which is mentioned inside this research paper? And I think yesterday I have discussed about it for odd number and even number. Or is it going to be something different? Yes. So doctor is saying rotational. Yeah. So byte pair basically rotational, like a positional encoding that we are trying to use over here. So let's write some function. This function is going to be even a bit more complex. But yeah, it's just a Pythonic function we are going to write over here. So we can try to write a class position, P-O-S-I-T-I-O-N, positional, E-N-C-O-D-I-N-G, positional encoding. And then positional encoding, we are going to do it for our object layers dot layer. I'm just writing a class over here, guys. Don't get overwhelmed by this piece of the code. At the end of the day, it will do what? It will try to generate a positional encoding. So in it, and just a constructor I'm going to initialize. So self, and then there is a variable I'm going to take, maximum length. There is a model. So these are the variable which I'm going to consider. Now, many people are getting confused with this window size, right? Now, let me do one thing. Instead of like writing this, maybe this word is confusing, right? So here, just to clarify it, I'm going to prepare one variable, maximum sequence underscore length length. And that is basically 100. Now, this maximum sequence length is equals to window size. Simple. Now, I believe this variable name is very much clear. This is the length of the embedding that we are talking about. As simple as that. Yes, length of the embeddings, the input one that we are going to create, or output one. Fine, maximum simple length. And then here, so we are going to basically maximum length and dimension of the model. Let's try to take it. And let's override. So we are going to call super dot init. Like I said, guys, don't get overwhelmed. I have already prepared my code, so I'm able to write it. Even I don't remember all like a piece of the code. But yeah, I do understand each and every word and lines, obviously. np dot I'll just explain you this code, don't worry. Maximum length. Numpy dot new axis. Yeah, new axis. So this is a POS position, and I, so numpy dot arrange. Okay, so arrange and then take a dimension of the model and new axis. So numpy dot new axis over here. Start from there, go till last. Now angle, a rotational encoding we are talking about, so obviously we have to rotate it. Angle underscore RATES rates is equals to 1 by numpy dot power POWER power. So power of what? 10,000. Now if you will look into this formula, power of what? 10,000. Same thing we are trying to replicate. So power of 10,000, and write the formula as per the research paper. So 2 into I modulo 2 over here. Fine. And then divided by numpy dot float 32, and then dimension of the model. Yeah. So basically, like what I have done over here, nothing much. So if you are going to follow along with this research paper, right? So same thing we have done. I believe yesterday I talked about a dimension of the model. So what is this D of the model, guys? What is this D of the model, by the way? Anyone who can recall? Okay, 512. So angle rate is done, then an angle radians is basically this part is a bit complex. Like only this part is complex because it involves a lot of like a calculation. Apart from that, like other part, I don't think that it's that complex. Numpy sine of angle rats. So angle rats, I have to angle rats is equals to positional encoding dot angle. Why it is not able to call angle rates? Okay. NumPy dot sign angle rats 0 angle rats. So basically for even and odd point, this is what I'm trying to say over here. So for even and odd point, as we have discussed as a part of our positional encoding, so we are trying to set it that for even like generate this, and for odd generate this. NumPy dot cos. So for odd point, we know that from a research paper that it's a cosec theta. Angle radians is 2:2, and then self dot pos underscore encoding is equals to TensorFlow dot cast angle radians NumPy dot new axis and d type is equals to TensorFlow dot float 32. Okay, fine. So this function is done. Def call so what it is going to return x plus self dot positional encoding Okay. So now what this function will do is, so as we have gone through a research paper, so basically for a even position and for a odd position, and even I have explained you in my yesterday's class. If you remember the positional encoding part, let me open up the documentation where I have explained you. Yesterday, I believe foundational model architecture, and then continued. No, I think I have not saved that part of the PDF. So yesterday, if you remember, so I have talked about how to create a positional encoding for the entire data set for even position and for the odd position. So I'm just trying to do the same thing. The only difference that we are trying to make over here is we are just trying to rotate it. That's it. And this is going to create a positional encoding for me by taking a maximum length and by taking a dimension of the model. Now, I'm not going to use it now as of now, I'll be using it in some time, but there is a error. Class 1 positional encoding. So layers, layers, layers. Okay, so it's a L capital, I believe. Layer. Okay, now it's fine. So just try to create this function, guys, and leave it as it is for now. Don't do anything. I'll try to tell you that when to use this particular function. But yeah, this function is going to solve a problem for me. And this is going to basically create this one. As per the architecture, we will be able to create this particular part. This one. So this part is done. Now this part is also done. We have written the function. We have not passed the data so far, but yeah. So we have written the function for this one. Now it's time for all the other part, which is a part of the architecture, so that I can try to create it. So let's go ahead and try to create a transformer decoder block. We are supposed to create a decoder block because we are trying to train basically a decoder only model. So one by one, what I will do is, so we'll try to create a decoder layer, and it's not difficult. Believe me, it's very easy. Just a play of library. That's it. Just a play of libraries. So it is very much easy. Within like a couple of minutes, we all will be able to create it, and even we all will be able to understand it. So here, what I'm going to do is, so we are going to write a function for creating a transformer block. TRANS. This is going to be amazing. So TRA transformer underscore block. So BLOCK block. So just create this function, guys, and inside this function, so we are going to create the entire transformer architecture with the help of all the inbuilt library. Now to create it, we need couple of things basically. So we need basically a variable called as embedding dimension. So embed underscore dim. So the data that will be passed inside this one, right? We need a number of heads, HEADS, right? So here we have n, right? Into n means number of like a head, like how many number of like a transformer that we would like to create. So we can try to pass that information over here. Number of head, that is the number of head which I would like to create. Now feed forward network dimension. Inside our transformer, we have what? We have a feed forward network as well, right? So we'll try to even create a variable for a feed forward network dimension, and maybe one optional variable. This is not mandatory, so drop out. So basically just to introduce a randomization over here. So dropout, dropout is equals to 0.1. Okay. Now once this is done, right, now layer by layer, let's start creating it. So can I say that when I talk about this transformer, everything is going to start from the input? Yes guys, input. Let's suppose I have created this one. I have created basically this input. So can I say that the very first layer is going to be input? Yes, input. What input? Obviously this input. Yeah. So let's start from creating a input one by one. So the very first layer is going to be the input layer. So what I can do is layers dot. So layers that we have done the import from a Keras. Right, this layers that we have done the import. So this is going to help me out. This library is going to help me out to create this layers. So layers dot input input. Okay. Now, so when we are talking about the input layer, so we have to basically define that what is a shape of the input, right? What is the dimension of the input? Now, what is the dimension of the input, guys? What is dropout? Dropout is nothing but, so let's suppose we have a multiple network and multiple layers. So dropout is equal to 0.1, means whenever it will try to send the data, 10% it will try to drop, means 10% network it will try to avoid, to increase the randomization, to make your entire network model more robust. You can try to even increase or decrease your dropout, or maybe you can try to remove it. That's also fine. But that is the meaning of dropout. Yes, guys. Now layers.input. Whenever we are trying to pass input, can I say that I have to pass a dimension that, okay, fine, for this input, this is a dimension. Now, what is a dimension? So obviously I have taken a variable over here, input dimension. So as a function, I will try to take that. So shape is equals to, I'm going to say that, okay, so shape is equals to none comma embedded dimension. So I'm just trying to give like a 2D over here. So none comma embedded dimension. So whatever dimension you are going to pass, whether it's 100, 500, 5000, it is going to take that part. So now this is going to be my input layer number 1, where you are going to pass the input. Now, once you are going to pass the input, as per architecture, what do we have? Can I say we have a multi-headed attention or masked multi-headed attention? Yeah. For example, like let's imagine like we have a multi-headed attention over here. So the next layer is basically a multi-headed attention that we have to create as per the decoder. Okay. So let's try to do it. So layers dot and then multi, M-U-L-T-I, why it is not giving me a suggestion, multi-head, yeah, so multi, H-E-A-D, multi-head, attention, A-T-T-E-N-T-I-O-N, hope I'm not making any mistake. So layers dot multi-headed attention, and then here, so we can try to define a number of head. So number of head is nothing but like number of such kind of a transformer which I would like to create. So number of head is equal to number of head as a parameter I am going to pass. Now key dimension, key underscore dim, sorry, I have made a mistake. Number of head is equals to number of head, simple. Then other parameter, key underscore dimension. So key dimension is equals to embedding dimension, EMB, embedding dimension. Okay. Now, so once we are able to like get this one, then we have to attach data with this one. So basically input comma input input. So input means input into input, we are going to pass it over here. So this is going to create a complete attention layer. I can name it as a attention OUT PUT, attention output. Okay. So from here I will be able to get a attention output. And if I have to maybe attach a dropout, I have not used a dropout as of now, right? Dropout simply means that I'm trying to create a randomization. Let's suppose I have a multiple layer, or think in this way, that we have a multiple neurons, a trainable parameter. So I'm trying to avoid some of the parameter on a random basis while doing a training. This is the meaning of a dropout basically. So let's try to use dropout. You can even avoid it, that's completely fine. So layers dot DROUP dropout, and then DROPUT dropout variable, and this is going to attach with attention output, the previous one, it will be attached with that. And again I'm going to name it as a attention output, this one, right? So this is again my attention output. Now, so after this, what we have to do is we have to add the normalization. So once we are able to build a multi-headed, then we have to add basically a normalization. So fine, let's call the library and then try to add the normalization over here. So layers dot layer normalization, ZITION, normalization. And then here there is a parameter called as epsilon, EPSILON, epsilon. So 10 into 10 to the power minus 6. So 10e minus 6. And here, so what we are going to pass? So we are basically going to pass INPUT input plus attention output. Now, so this is the layer normalization. Look closely into the architecture. Now, when you will try to look into the architecture, for example, like additional normalization, if I'm talking about, so this layer is taking what? Can I say this layer is taking output from a multi-headed attention? Yes, output from the multi-headed attention, plus it is taking input as well, the input as well. So it is taking two things, right? It is taking two things. And that is the reason in my code, if you will check, so I have written these two things. So I'm trying to pass two data set over here. So one is a input and one is a attention output completely as per the architecture that we have discussed. Okay. So here, out one, maybe I can try to name it as a out one. Is it making sense to all of us, guys? I believe this piece of the code is easy peasy, not very difficult. Masking I have not added so far. Masking I'll try to add. Yeah, this piece of the code is easy to understand. Fine. So once this part is done, so if any one of you are not able to understand any line of the code or any word, do let me know. I'll try to explain you once again. But I don't think that this is like a tough code. So TensorFlow.keras. Now what I have to do is I have to basically build a feed forward network, right? Feed forward network I have to build. So let's go ahead and let's try to build a feed forward network. So fine, not an issue. I'll try to create one variable and I'll try to build a feed forward network. So like tf.keras, and then inside that what I can do is so I can try to write layer layers layers dot dense, and then feed forward dimension I can try to give, and then activation function activation activation wise I can try to give a ReLU for a feed forward network, and then layers layers dot dense, and then embedding dimension. Now I'm calling this as a feed forward network, FFN. I've just given a name of this variable is equal to FFN, right? Feed forward network. Now, so this is the feed forward network. I'm just giving a dimension. I'm giving an activation function. We know that it's going to be the neural network, right? So now what I can do is, so we can try to attach this feed forward network with my output. With what? With output. Why? Look into the architecture once again, right? So let's suppose here we have a feed forward network, right? Now feed forward network is trying to take what? Output of this. It is trying to take feed forward network. So this is what we are going to do. This is how we are going to attach it. So here feed forward network, and then I'm going to attach it with the out one. The output that we have received from here, I'm just sending into the feed forward network. Now this is going to give me the output. So feed forward network underscore put, I'm going to create a variable and keep it over there. And then once I will be able to get an output from a feed forward, again maybe I can try to call a dropout just to make my model like a more robust. And this is what has been done in GPT 3.5, dropout, dropout. So dropout from what? Feed forward network output. Okay. Now feed forward network output is equals to this. Fine. Now, so once I'm able to get the output, then again I'll try to add the layer normalization. So as you can see, after feed forward we have a layer normalization. We can try to add it. Let's try to add it. Layers dot layer normalization, and then the same thing I can try to copy and paste. Okay. And here, so I'm going to attach what? I'm going to attach output, and I'm going to attach feed forward output. So output 1 plus feed forward output I'm going to attach. So in this layer, why? Again, check the architecture. So here you will be able to find out that over here we are attaching the output of this feed forward network and the output that we have received from the attention, from this one, output 1, right? As per our code, output 1. So these two output we are sending inside this addition and normalization. So exact same thing we have done even inside our piece of code. Okay. There is a typo in first dropout line of a code. Not an issue. Anyhow, it will give me an error. I know there are a lot of typo. It will give me an error when I'm going to execute it. So at that point of a time, I'll fix it. Return TensorFlow.keras.model, and then model wise inputs is equals to input that I have created, and then output output 1. Sorry, I can return this output, right? Let me write it down as output 2. So output 2 I will be using as a return. Okay. So this is now, this entire function is technically created the entire decoder transformer. We are not using this masked multi-head attention. So what we have done, so we have just utilized, right? We have just utilized this one, this much of architecture, this much of the decoder architecture as per GPT 3.5, right? So only this much of decoder architecture we have utilized. If I would like to add this one as well, I can just add it. It's very easy for me, right? I think now every one of us will be able to add it just by looking into the code. One more layer, and then similarly output and input. So this one we are able to now create. This is one of the transformer we are able to create it. Making sense, guys? Yes. Isn't that the same as encoder? Yeah, it looks like the same as an encoder. I'm not saying that it doesn't look like an encoder. If I'm going to ask, or if I'm going to add a mask multi-head attention, then in that case, it will become a decoder. It actually looks like a encoder, you can say. But depends upon me. I can keep on changing it. I can say that, okay, fine, it's a decoder. Means when I will try to say that as a decoder. So see, the major difference between encoder and decoder is, so encoder, whatever encoder is going to generate, so that generation or that sequence will be used in some other network. So encoder, whatever output encoder is going to give, that you will not be able to take it as a output, a final output. Whereas this is the major difference, a philosophical difference between encoder and decoder. Whereas if some network is giving you a output, a final output attached to a final output, that is eventually called as what? Decoder. Hope it is making sense and you guys are not getting confused. Yes. So encoder is technically going to give you a intermediate output. It's just like a naming convention. Yeah. Okay. Now, so once we are able to do this, now move ahead, execute this part, and this looks good. Now let's write a function. So we are able to build a transformer, which is a major part, right? Transformer is done. Now let's try to accumulate each and everything that we have. And now it's time to build a GPT model. The complete GPT we have to build by attaching each and everything, the things that we have already created. So here I will try to create a function called as build underscore GPT underscore model. So far I was trying to build a component. So if you remember, so from our beginning, we were trying to read our data. We are tokenizing it over here. Then after tokenization, what we have done, so we have converted it into X and Y basically. Then we are trying to create a positional encoding. Then separately, we have created a transformer layer, right? Transformer layer. Now what I will do, I'll try to accumulate, I'll try to attach each and everything, and then I'll try to build the final GPT model, right? So here, when I'll try to build a final GPT model, so obviously I'll try to start from the input. So layers dot input, and my input is going to be what? So my input is going to be nothing but maximum sequence length, the 32 or 100 that I have taken, right? So this is going to be my input. The data which I have created, my X data, that is the length of the data, right? So input. So that I'm going to call it as a input for now. And those who is looking for this code, let me ping you this code. Yeah. So now code is available inside your chat box, guys. Okay. So now GPT first layer is done. It is going to take my X data, the X data that I have created. Now layers dot embeddings, EMBEDDINGS, embeddings. Now input underscore dimension, input underscore dimension. Now what is the input dimension that we are going to consider, and what is the output dimension that we are going to consider? So we have to give a input dimension of the data, and we have to give basically a output dimension of the data. Now let's try to do one thing. So let's try to create some of the variable which I'm going to use it eventually over here. So there is a variable called as vocab size, vocab underscore size. Let's suppose I'm going to keep a vocab size is equals to 5,000. So 5,000 odd words I'm going to use. maximum sequence length, I have already created a variable, just overriding it. Over there value was 100, even here value is 100. embed underscore embedding dimensions, I'm going to take it as a 256, let's suppose. Number of underscore heads, number of heads, I'm going to like create maybe 8, 10, 16, whatever I want. Feed forward network dimension, I'm going to take it as a 1024, let's suppose. Number of or layers is equals to 4. Batch size, I'll explain you all the variable. Batch size is equals to 32. Epoch, number of times we are sending a data, whole data, is equals to 10. Now these are some of the variables that we have built. One by one I will be using all of these variables, right? So just create this variable and keep it with you. Now here, so layer embedding, so what is going to be the input dimension? So input dimension is nothing but going to be, let's suppose, vocab size, basically. So vocabulary size, whatever vocabulary that we have, so we are going to pass output dimension is equals to embedding dimension, and then we are going to pass this one into this one. So this is how both of these lines are connected. Now this is my x, let's suppose. Then inside this x, the embedding that we have created, we are going to attach our positional encoding. So let's call our positional encoding function, and the positional encoding function was taking what? It was taking maximum length and dimension of the model. Okay, so I'll try to call that class maximum sequence length. I'm going to pass embedding dimension, I'm going to pass, and then attach with the x. So now after this point, my input is completely ready. After this line, after connecting this layer embedding and positional encoding, so my input is completely ready. My x is completely ready. It simply means that this one is ready now, right? This one is completely ready. Now, once this part is ready, what I will do is I'll move to the next part. I have already created the layers, so I'll just have to connect and attach it. So here, once my input is ready, what I will do is I'll try to create a stack of transformer block, right? So here nx is mentioned, so I'll try to create the stack of the transformer, like a layer that I have already created. So here, to create a stack of this one, I have to run inside maybe a for loop, and number of layers, I have already created a variable, number of layers variable. Maybe I can try to keep it like a 440, 400, whatever I want, right? For example, in GPT 3.5, they have used like a 96 head, I believe. So 96 I can try to give. So 96 number of, so that is the number of complexity we are trying to increase. So here I can write a for loop. So for like in a range of basically a number of layers variable that I have created, right? So just try to create what? Just try to call that many number of transformer block, as simple as that, right? Transformer block, the function that I have created, this transformer block function, right? I'm just calling it here. So that just try to create these many number of the transformer, stacking of these many number of the transformer. What input it is going to take? So it is going to take a embedding dimension is equals to embedding dimension, and then number of heads. So what is the number of heads it is supposed to create? And for feed forward network dimension. Yeah, so it is going to take embedded dimension, number of head, and feed forward dimension. So I'm just trying to pass each and everything inside this one. That number of head, let me, yeah, so this is fine. Variable name, and against that data. So this is going to create that many number of the transformer for me, basically. So fine, transformer will be created over here. Now, once this many number of the layers will be created, my for loop is going to create it. Then on top of this one, I'm going to add what? So I'm basically going to add my activation function. So here, as you can see, linear and then softmax. So I'm going to add this softmax basically so that it will be able to give me the final output. So now all this number of like layers has been created. Now connect this layer with the final outcome. So here what I will do is, so I'll try to like create output variable out put out output variable layers dot dense vocab size activation function wise. So I'm going to give a softmax activation function, and basically it is going to take an input from X on the previous layer. And then eventually I'm going to write that return. So final return. So TensorFlow dot keras dot model mcap model and then input output. Yeah. So take input and output. So this is something that it is going to return. So this is going to build my whole GPT layer or GPT model. So it is taking input and finally it is going to give me the output. So let me ping you this piece of the code. Okay. Now, once GPT is done, GPT is built, we are able to connect each and everything, whatever we have built before. Now what I'm going to do is, so I'm going to call this one and then execute this GPT model, right? Now it's time to execute it. So here we are now coming closer to our training. So just call build GPT, and for sure I'm expecting some error over here. So model dot compile, and compile what? So at the time of compilation of the model, we have already seen while we were talking about RNN LSTM that we have to pass the optimizer, we have to pass the loss function, right? Optimizer for updating the weight and loss, basically to calculating a difference between y and y hat. So optimizer we are going to pass, and we are going to take Adam optimizer over here, right? Adam optimizer, which will help me out to change my weights. And loss function wise, so I am going to take a sparse sparse categorical cross entropy. So and then I'm going to like, this is just an optional parameter guys. So accuracy. Okay. So this is going to execute the entire model. So now Keras has no attribute embeddings. Module, this one layer embeddings. Okay. EMBE. Okay, it should not be S, it should be only embedding, I believe. Object has no attribute, angle rate. So angle radians POS, angle rate. Positional encoding, angle. Model Keras layer has no attribute, dropout. So where? Here, line number 4. Attention dropout, layer dropout. Okay. DROP. OUT. Okay, keyword argument not understood input. Yeah, there is a lot of typos. It happens. Keyword argument not understood input, and I'm getting this one, line number 16. TF Keras model INPUT input. TF Keras input. This input is fine. So yeah, looks fine to me. Transformer block. Okay, now everything is fixed. Now I'm pinging you a code, guys, one by one. So for a positional encoding, take this code. There was a lot of typos, so I've just replaced with the fresh code. So now this is one. In a sequence, you can try to take it. This is the another one. And finally, I'm able to create the model. Yeah. Finally, I'm able to create the model. Now, once I'm able to create the model, so what I can do is I can just like call the model and start the training. As simple as that, right? Model object is created. So I can try to call model dot fit basically. And inside that, we can try to pass our X data, right? We can try to pass our Y data, just like a machine learning things that we do. So try to pass X data, try to pass Y data, try to pass a batch size over here, right? So batch size is equals to batch size that we have defined. I'll tell you what is the batch size, by the way. Try to pass epoch for the model. So epoch is nothing but the variable epoch that we have created. So epoch, and then try to call a validation. Validation is split for a testing purpose. So basically it's only 10% data which I'm giving for a testing purpose, and then callbacks. Or maybe yeah, I can try to like create a callbacks, or leave it for now. Okay, so now this is basically a model, and we are trying to like fit this model. Now what is the meaning of batch size, by the way? Now here we have defined batch size is equals to 32, right? So basically 32 data it will try to pass at one go. As simple as that. Means if we have 700 data, so just try to divide 700 by 32. That many number of times it will try to pass the data just for one iteration. Epoch means what? Epoch means passing a whole data. So here we are trying to say that epoch is equal to 10. 10 means I will try to pass whole data 10 times, right? 10 times. But even in that one time, generally people get confused between the batch size and this epoch. So let's me like keep it very, very clear for all of you that when we are saying, let's suppose we have 100 records, 100 number of rows, right? Now, so let's suppose I'm trying to say batch size is equals to 10 for this 100 record. So total record will be having how many batches? 10, 10, 10. Like that, we will be having 10 such batches. 10 such batches, right? 10 such batches. For example, we have a data science batch, we have a generative AI batch. So in every batches, we have some strength, right? So in some batches, we have 200 people. In some batches, we have 500 people. So basically, that's a batch, right? 200, 300. So here, what is the meaning of this batch size? So meaning of this batch size basically is like this much. So I have total 100 data. I have just divided it into 10, 10, 10, 10, 10. So one batch, one size of the batch is basically 10. So 10 data I'll try to pass in one single go. Now, what is the meaning of epoch? Epoch 10 means 10 times I will try to pass the whole data, right? Whole data. So it will try to go for the iteration how many times? 10 into 10. Technically, it will try to go for the like you will feel like that it is trying to go for 100 times of iteration, but technically it is going for like 10 times of iteration. 10 times I'm trying to send my data to my model. That's it, right? So this is the meaning of the batch size and the epoch, and you have to like tell these things to your model that how many times you have to see the data. So 10 times it will see the data, and every batch size is basically 32. Okay, so this is model.fit. Now I'm going to execute it. If everything like is going to be fine, then it is going to train the model. So as you can see, epoch 1 of 10, epoch 1 of 10, estimated size ETA is equal to 21 second, loss is equal to 7.75, accuracy is equal to 0.023. So now guys, training have started. As you can see, we have started the training. Means everything is working well and good for all of us. So how many of you are able to start the training, guys? Now epoch 1 is done. So all this like a 22 set of the data, it is able to send. Now epoch 2 is running. And as you can see that it is able to decrease the loss, right? It is able to decrease the loss, means my model is learning. So how many of you are able to now epoch 3? How many of you are able to start the training, guys? Anyone who is able to start the training? Okay, so Puran is saying attribute error, track most recent call last. Okay, so what I can do is maybe I can try to. I have started. Dev Kumar is saying he is able to start. Uh, let me do one thing, document, and then where is the folder? GPT. So I will try to convert it into a GIF file and let me upload it, guys. Document and then GPT. Yeah. Now here is the complete file. So whatever like data that I have, so you have the same thing. So you have a tokenizer, pickle, IPONB, everything. So I've just like send you inside your chat box. So I'm in a epoch 5. So I'm into a 7th iteration. Yeah, it is A range actually. Though I have started with another data, you can start with any data, any random data. That's completely fine. That is not going to create any kind of a problem, I believe. So epoch number 9. So waiting for the 10th one. So my mini GPT is getting trained, by the way. They were saying, although I have started with another data, yes, I'm not facing any issue. Yeah, I don't think that anyone will face any issue. If you're facing some issue, maybe use my code or maybe try to ask Yuri to fix that code. Yuri will fix it. So I'm not able to see much response inside a chat. What happened to other people, guys? I have already pinged you the code, complete directory. At least now you should run it. So run the entire code base, at least. You have my data as well. Okay. So all this 10 epoch is done. It simply means that my model has been trained for whatever configuration that I was like trying to train the model. Yeah. Now what I am supposed to do. So maybe I would like to do a little bit of investigation over here. So maybe I would like to like save the model as a physical file. So first of all, what I will do is I'll try to save the model. So I can try to call model dot save, right? So that my physical file will be available with me. So model dot save GPT underscore test underscore gen AI underscore class dot h5. So like this is the name which I am going to give and save the model. So as you can see, I have this dot h5 file. So in dot h5 file format, I am able to save the model, a physical model, right? Now let's suppose I would like to check or I would like to see a layer by layer information. Again, for that there is an API which is available. So model dot summary for any models actually, not just for this model. So there is a like a method called as summary. Now this is the layer, guys, that we have created. Are you able to see it? Model dot summary. So the model actually that we have created. So layer by layer, it is trying to give you the information. So it is having the input layer. What is the shape? 100. I think we all know why we are getting 100, where we have kept 100. Then there is a embeddings layer, right? So where we are trying to convert our data into 100 into 256, 100, 256 such data. This is the number of parameter. Now there is something called as positional encoding that we are trying to do with the same data, same like length, as you can see, same dimension. We are able to do a positional encoding. Then what we have 4 layer of attention. Yeah. So we have basically 4 layer of attention. So as you can see, we have 4 layer of attention over here. And in every layer, how many parameter we have? So we have, yeah. So basically 2.6 million. Yeah. So 2.6 million in one layer, then 2.6, then 2.6, then 2.6, then 2. Like 1.2. So these are the number of parameter that we have in 4 layer. And then total number of parameter that we have is approximately, okay, so it's in a crores basically. Yeah. So it's like a 13 million parameter that we have. And total parameter is this much. And what is the total trainable parameter? This is the trainable parameter. This is the model size. So if I'm going to increase the number of layers, right, my model size is going to increase. My model size is not going to be same at all. Now this is the layer wise summary that you all are able to see. Even I can try to like call Netron. So Netron is a visualizer basically. So I can go to Google, Netron, Netron, I can try to call, and here, so I can try to upload my model. I will be able to see like what is there inside my model. So input, then embeddings we have, right? Then positional encoding we have, then 4 layer of transformer we have, and then 1 feed forward network is there, and then it's connected with the final dense layer. So this is the visualization of the model you will be able to see. So same, like the file that you have saved it, call it inside the Netron. I think I have already introduced Netron to all of you. So you will be able to see your model and you will be able to see the layers, right? The layers as well. Now, so I'll just try to go to Google LLM visualization. So this is something that we have been using, right? LLM visualization. Now in GPT-3, how many layers are there, by the way, guys? How many layers are there? GPT-3? How many layers? 96, right? Okay. If I would like to create something similar, not an issue. I'll just go over here, number of layer, 96. Now you will see the size, actual size of the data. I'm not going to call the, okay, it's compiling. I'm not going to call a fit because it will take some time. So I'll just directly go to the summary. So now if I have changed 96, now if I'll just call the summary, I'm not calling fit. Without calling fit, I'm going to call the summary. Now just see what is the model size. Your model size is approximately 1 GB. 1 GB. Previously it was like a 45 MB, right? 1 GB. Now see the parameters. So when people say, for example, recently, if I'll go to Google and Hugging Face, HUGING, Hugging Face, Maverick or Euron, we have Yuri. So inside Yuri, we are giving you a scout, right? So basically a scout. Now, like there are a lot of parameter which is available inside the scout. So you can try to go and check all the detail, and maybe you can try to like build a similar kind of a model, right? Build a similar kind of a model, just layer by layers. Just imagine like 1 GB of size of the model. So just imagine how much like time it will take to just for doing a inferencing. Again, I can keep on modifying each and every layer as per my requirement, right? There are a lot to do, but yeah, 96 layers. Okay. So GPT-3, we are able to build it. Obviously we will do a little bit of modification only, right? And we'll try to pass a huge amount of data. My work will be done. That's it. Maybe I'll try to play with maybe a input context length, or maybe I'll try to play with some positional encoding over here. I'll try to play with the vocabulary size or maximum sequence length, embedding dimension, all of these things, right? I can try to. The code you shared has a error, is it? Okay, just wait. Let me share this one then. I don't think that it should have an error. Compress to zip. Let me share a fresh file. So ChatGPT guys, we are able to build it. Uh, Generally, on how many epochs models is been trained for? So maybe like a 10,000, 20,000 epoch. But again, so the time which one epoch is going to take, it depends upon your data as well. We have a very small data. Yeah. So we have a very small data. I think the file size is too huge. It's like, yeah, uploaded. Fine. And again, you can go and check for all the open source model that for how many epoch, for what kind of a data, what size of the data it's been trained. My data set is available in just a KB, right? It's a very small data. It's a KB of the data. Now, this is done. Now, what we can do is we can try to check this model, right? We can try to check this model and we can try to test it that whether I'm able to get a response or not. Basically, whether I'm able to save the model, as you can see, H5 file. A good model or bad model, that's not a concern basically, because I know I can try to make it as a good model, right? So I can try to tune this model. I can try to run this model for the multiple epoch. I can try to like pass more and more data, and then like it has a model, I guess. Yeah, I've just been to the code, like a fresh code, Purna. Yeah. So now if I have to test that, so how many of you are able to build it, guys? Your own model? Yeah, in chat, please. Waiting for your response. And are you feeling excited, or like this class is like very boring? How does it feel like? Yeah, guys. Okay, amazing, fine. Now we are able to build the model. Now it's time for inferencing. Inferencing means get the output. So I'll just copy and paste the code. I don't think that it's a very heavy code that we have. So I'm just trying to load the model over here, nothing much. I'm load a tokenizer both, so that whenever I'm going to pass the data, first of all, I'll try to call tokenizer, tokenize the data. So let's suppose if I'm going to ask the question, and then finally what I will do is I'll just try to pass the input into the model. So I'm just loading the model and tokenizer. What is the issue? No file or directory found in GPT model final file. Okay, I've just used the pre-built code. Let me change the model name. Model name is basically this. Yeah. No, I will not give that. Fine. So I'm able to load the model. I'm able to load the tokenizer. So both the file I'm able to open up. I'm going to send you this code. Please try to test this code. And please try to test your model as well. So for whatever data you have trained, test it that whether it's working or not. So this is basically for a loading. Now there is a next piece of the code which I'm going to send you for inferencing, for generating a data. I'll explain you this code if you want. I don't think that it's a very difficult code. So this is a code for generating a information that we have written. So here is a code for generating the information. Now what I will do is I'll just ask the question, right? I'll just ask the question. I will simply copy and paste. This is my pre-built code which I was testing. So my name is, who is Sudhanshu? I'm going to ask. Who is Sudhanshu? Execute. Oh, I have changed the layer, right? So it should be like 100. Okay, so it is generating something. So who is Sudhanshu? So rupees 250 was accessible, raised from continuous Sudhanshu acquisition, February 24, Jharkhand earning affordability, early limited was providing 2022. Can I say that it is able to generate some like not 100% meaningful information, but at least 1-2% of meaningful information just with 10 epoch small data? If I'm going to train it like for a 1,000 epoch, same model, and if I'm going to increase even the number of layers, right, same model is going to perform in a best possible way for my data set. But can I say that even this looks amazing? Yes, guys, everyone, it is able to understand who is Sudhanshu little bit, and yeah, it is like able to, you know, give some like respective answers. Yes, from my documentation. So I think 250 crore was mentioned, right? Like the acquisition price. So it's bringing from there. Jharkhand is a place from where I belong. All the information are relevant. It looks like in a tokens. If I look this information in terms of tokens, it looks like very much relevant to me, right, guys? Sir, here accuracy is very low, so we can't. Obviously, I can make it accurate in next 2-3 hours of training. If I'm going to put it for a training now, and with the multiple epoch and with increasing number of the layers and with little bit of fine tuning, within 2-3 hours after 2-3 hours, you will be able to see that my result is way better. Way better means literally way better. I have just trained it for 2-3 minutes, right? I have just trained it for 2-3 minutes only, and it is able to understand my data. Yes, only in 2-3 minutes of training, right? And that to like not with a heavy compute. So can I say that we are able to create our own GPT? Now I can go and claim openly that yes, GPT-3 I am able to build it. No one is going to say like you are like telling lie or something, or maybe you are like trying to exaggerate something. No one is going to will tell you, because this is how exactly GPT-3 is been built. Yeah, obviously data was huge, compute was huge. That's it. That's the only difference. Apart from that, there is no differences. You will be able to find out what is the computational power required. I think for this kind of a data, I don't need a much compute. My computer is more than enough, even for 1,000 epoch. So I have like a 24, I have this like a computation power in my system, as you can see. So I have 96 GB of a RAM, as you can see over here, and Yeah, 48 GB of a GPU. So, and I have graphics card RTX 4090, latest one, and 6 TB of hard disk. So I think this is more than enough for at least this kind of a data. This machine itself is big. It's not the small one. So even with like a slightly bigger data, my machine will be like good. And for 10 hour, 20 hour, I can like do a training and I will be able to get an amazing result on my own data at least. So now I believe you all will be able to build your own GPT. Right, guys? Yes. GPT, Llama. I think all of you can build anything and everything. Like if you know the architecture, you can just go and build it. Will you be able to do it or not, guys? Yes? Fine? I think you should just know the layers, right? So what is the layers that we have? Because we understand the base, like a transformer. So I just know about the layers. And if I have a layers, layer by layer, I'll keep on connecting it. And yeah, I'll be able to build the entire model. Fine? So now even you can build a GPT. That's the reason. So entire world is able to build a GPT, but in India we are struggling a lot because the major problem is not a research or not this. So major problem is what? Major problem is actually two in terms of building such kind of a model. Obviously, research is one part. Someone has done the research. Someone has, created this entire paper and theory, and then they are trying to do a fine tuning on a regular basis. But the bigger problem is not this, right? We have a researcher in a country. We have like everything. The only thing that we don't have is a data access, right? Because we are not holding any kind of an international grade platform, so which generates a data. We are very bad in terms of acquiring a data. The very first part. The second part is compute power, because H100 kind of a GPU, NVIDIA H100 kind of a stack of GPU is required, which costs not just 1 or 2 rupees just to train one single model, right? Just to train one single model, it requires hundreds of millions of dollars. So basically it requires a 700 to 800 crore rupees. Just imagine. It is giving a enjoying result which has started with 250 crore. Yeah. So basically that is the major concern. Just imagine 700 crore rupees, 800 crore rupees, right? Or obviously DeepSeek was able to bring that down by like, I think 40 times. I don't remember the actual number, right? But yeah, DeepSeek was able to bring it down to that one. But even that amount is very, very huge for any startup, at least in India, right? Because in India, people don't understand a deep tech. They don't understand these things, especially investor, if I'll talk about, right? So this is the two major problem which every country is facing, and those who are not facing it, they're building it. Otherwise, it's not that difficult. But yeah, difficult. The two part data itself is a very difficult part to acquire. But we have a supercomputer with CDAC. We don't need a supercomputer. We need a stack of series of computation, right? So supercomputer is not going to help you out. It's better for like some sort of a regular computation, but not for this kind of a training. Hope your third startup would be on. I don't have that much of capital. Obviously, I have a lot of dream to build, and I'll give a try for sure. Right. So I'll give a try. Let's see. So what future holds. But yeah, I have a lot of dreams. So of doing such kind of things. And maybe you guys can do it. You guys can try this out. Maybe on a small scale, right? There are like infinite number of opportunity that AI is going to, AI has already opened up for all of us. Just go and leverage it. Yeah. So can you explain how the water and other resources were consumed while the models are using? See, we are training a model. So obviously you are trying to spin a machine. Even while collecting a data, you are spinning a lot of machines. Now, eventually those machines, right, that we are talking about, that machines needs a cooling system. That machines needs a very, very high amount of electricity. You're talking about H100. Just go and check what is a watt or what is the energy consumption that H100 one single rake will be having, or one single slot will be having for 1 hour. And then just do the computation for maybe like 1,000 hours or 2,000 hours, 5,000 hours, which is required to train the model. And that too, not just with one plate, with thousands of plates. Yes. So this is where water energy and all this like things, ecosystem comes into a picture. IIT Madras is working on the CPU on the compute purpose. What your take on this? See, like working and all those things is fine. We keep on saying, and we like every day we see. You have not seen that by yourself, right? So basically, we see everything in a newspaper, in a PR. Do you think the things that you read in a newspaper is correct? It's called as, that's the reason it's called as PR. It's not correct, right? It's just a hype. People are trying, like every business nowadays, like they're just trying to create the hype. They're just trying to spread unnecessary news by like paying 10,000 rupees for one news article or 5,000 rupees for one news article. So that's a reality we are living into. And as a common man, we don't even realize it. But yeah, we do know these things, how these things happens basically, right? That like even after 2 years, 2.5 years, we are not able to create anything. If everyone is working, if we have so many IITs, if we have so many resources, if we have so many of everything, then in 2.5 years, why we are not able to create it? And every day we are like able to see some news that we are building this, that, blah, blah kind of a things. But at the end of the day, result wise, sunne bata sannata. Okay, so enough of discussion for today. Fine. So you guys can try this out. I think that will be amazing, right? Maybe you can try to take a Llama model, initial Llama model, Llama 2 you can try to take. The architecture is simple, right? Almost similar to this one. And maybe you can try to train like 70, 90 hour work hour or debate. I'm like, I don't think that we should even talk about the 70, 90 hour. I mean, like whatever it takes, just let it be. If it takes 900 hours, let it be in that way, right? And if you don't want to work, it's completely fine. There is no issue. There is no pressure at all. Your life is your life. So unnecessarily we are debating everywhere like 70 hour, 90 hour. I'm like, that topic itself is an unnecessary topic, right guys, everyone? I don't think that we should even talk about those 90, 70 hours. I mean, like whoever has to work 90 hours, it's fine. Whoever like have to work for 10 hours, that's completely fine. Your life, your rule, enjoy, chill. Sir, please arrange a session about the open source contribution like today. We'll think about it. Can we have a problem to solution class someday? Can we have a problem to solution class someday? So what is the like? What do you mean by problem to solution? Sorry, I'm not able to like understand your question properly, doctor. Maybe if you can like rephrase it. Sir, by further we can see a mass multi-threaded. Yeah, just call the API. You will be able to get it. I'm getting few problems. Will try to fix on my own. However, class is great. Thank you so much. Hope all of you are liking it. Let me share a latest version of the code where I have done the inferencing. Now what I can do is the next step will be, I can try to build maybe a Streamlit kind of a app, and then I'll just try to do these things with the help of UI. If you want in a next class, I'll do that as well. So I'll create a proper UI, like a ChatGPT kind of a UI with the help of a Streamlit, or with the help of even like a React. I can create it. I don't have any issue. And the React and Node, and then like just like ChatGPT kind of interface, and you will be able to chat with your own model. That's also possible. Yeah, what is the question, Kumar? Any library which converts Hindi transcript text into a Hindi transcript text into a English token? You're talking about like text to text, right? Conversion basically. There are a lot of models. So go and download it from Hugging Face. For Hindi, there are enough models which is available. Sir, will you also fine tune a GPT model with custom data? Yeah, Ravi, obviously. See, but when I can teach you how to create a GPT model, fine tuning is not a big deal for me. Hope you understand, right? And when the entire class, right, entire class now knows that how to create a GPT, then guys, do you think that if I'm going to discuss fine tuning, it will be very difficult? Yeah, because now we all know that how to create it basically. Yeah. Devani is saying, please include a voice chat option even. I think I'm available everywhere. Like I'm available here. I'm available in your WhatsApp group as well. Even I was like directly responding to a WhatsApp group many times. So yeah, feel free to talk about anything over there or anywhere. Yes, guys. So when, believe me, when I'm going to talk about fine tuning, you will not face even a slightest of pain. And you will be able to understand everything. And even you will be able to explain same things to anyone in this world. Yes, because now we know how to create it. So fine tuning obviously will come after this, right? Fine tuning will not be much difficult as compared to this one. Can you please zip the current code and share? I want to train mine. Training part is missing. Okay, fine. I'm doing it. So let me delete a model file because it will become a bit heavy. So I'm keeping data and GPT IPYNB. GPT. Delete the older version. GPT. Okay, so compress to a zip and yeah. So Jitendra, here is the latest version, and for everyone, guys. So latest version. So where we have a code even for inferencing. So where I'm like able to ask the date question and it is able to give the answer. So I have already pinged. When hybrid course will be launched? Very soon, launching day by day, new things. So just wait. At the end of the day, you will be able to get everything. Don't worry. Although it's Mac still running on Epoch 1. So which Macs on those? What is the series that you're using from Mac? Even going forward, no, I will be talking about quantization. So there is a concept called as quantization. So where we can try to make a model lightweighted. For example, it's if we have to deploy a model into edge devices, right? So there is something called as a quantized model that we try to. Edge devices means a Google Coral, Jetson Nano, JVR, or even your mobile devices. So it should not be hosted over the cloud. It should be hosted inside your mobile devices, and you should be able to do the conversation even in an offline mode. So going forward, I'll tell you, even just give me a reminder. It's a small concept of quantization. So where we try to chop off all the floating parameter values, right? So that compute will be a little bit lighter. And the model size will be smaller in that case. So that is something which I can discuss. And again, it's an amazing concept. So I think we all should know about it. I don't know whether I have mentioned that inside your syllabus or not, but yeah, just give me a reminder sometime. So I'll do it. M1 Pro 16 GB. I don't think that you should face an issue. Epoch 1. Thank you. Learn the concept of GPT is a very easy way. The most important understood. Yeah, now you can understand any LLMs. It's not a big deal at all for any one of us. Sir, when we can expect internship? One by one. Team is small, guys. We are not earning much, so can't expand a team overnight. My dream is to expand a team overnight, but yeah, can't do it. We are limited with the fund. So, but yeah, we will build it. It will take time. We'll build it. Samir is saying finally code is running with the latest share code. Thank you. Great, Samir. Great. Okay. So hope all of you have liked it and all of you have enjoyed it. And many things to learn now, right? Many things to learn in the future. So if you want, I can even create a UI interface and I can even show you that how to do a inferencing through a UI. So maybe next class I'll do it. It will not take more than half an hour of time for me. I'll just create not a fancy UI, a simple UI, basic UI with the help of Streamlit, and I'll just try to call the same model. Then you're saying, okay, code is running fine now. Cheers. Okay, cheers to you. So with that, guys, thank you so much. Thanks for joining. Thanks for participating, and see you again tomorrow. Yeah. Sorry, not tomorrow. Tomorrow is Monday, right? Today is Sunday. Okay, we don't have class tomorrow. Next weekend, so Saturday. UI will be great. Okay, I'll do it. It's not a big deal. I'll do it. Next class, Saturday. Okay, so fine, guys. Thank you so much. Take care. Spread the news that we are able to build our own GPT, a smaller one, small data, but yes, a real GPT, we are able to build it. With that, thank you so much, guys. Take care, everyone. Enjoy.